so we just discussed this query before the break, and we saw that it's hard to write such a query because you have an aggregated function over another aggregated function. So how can we do this? One way to resolve this problem is to use views. And what are views? Well, relations that are defined with a create table statement exist in the physical layer. Right? So whenever you write a create table statement and then you insert values into that, that means there's a table in the physical layer that is storing that information. However, you can also create views, virtual views, that don't physically exist, but they are defined over the physical tables that you currently have. Okay, so I can define a virtual table based on the current tables that I have, which doesn't actually add anything to my physical layer. It's rather a conceptual table. Why do we use views? There are multiple reasons why you may want to use views. One reason is to hide some information. If I'm using the same table to store all the students at UBC's information, then I don't want to give access to all the departments for all those students. In the computer science department, we should only be seeing students in the CS major. So if I have a table for all students, then I'll create a view for the CS department that only allows me to see people in the CS majors. So one reason could be to hide information. The other could be that it would make writing queries easier. If I'm writing queries, which is gathering information from multiple different tables, and I'm doing this quite a lot, then it might be easier for me to write a view where that view contains all the information that I need. Then it would be easier for me to write queries just to query that view instead of all the different tables. And sometimes, database, your data changes over time. So you start with what you think is a good design, and then things keep getting added to this, and at some point it's not really a good design anymore. One way to deal with a bad design is to write views so it will look different to what it actually is. And it will make it easier for you to work with that database. This is create view, so you can say create view, a view name, as a view definition, where that view definition is an SQL query. So when you write an SQL query, what's returned is a relation. Now you're saying whatever is being returned, save that as a view. From now on, whenever I say select star from that view name, the same thing will be returned to me. What this means is that now I can have a view which is defined over relations R1 to Rn. Right, so there are multiple tables there. And I can query Q by looking at this view, and it would feel like to me that I'm just doing a query over one table, but in reality, it's going through multiple tables and joining them together in order to return the result to me. But virtually it would at least seem easier for me to understand what's happening. Here's an example. Let's suppose I have two tables. I have a course table where I have course number, I have title, and I have department. And I have an enrolled table that I have course number, student ID, and their mark. Okay, so these are the two tables that I have. I can create a view, course with fails, that keeps the department, the course number, and mark. This is what the schema of that view is going to look like. And this is the SQL query which is building that relation. So this view is coming from the course table and the enrolled table, where C.department equals E.department. And C dot course number equals E dot course number. And mark is lower than 50. So that would allow me to have information on everyone who's failed the course. Question?
Let's say you store this view, right? How do you find the key to access it later?
So the question is, how would you access values in this if you store this? Well, first thing is I'm not going to store this. I'm going to conceptually store it, but that doesn't mean that I'm going to write anything new to my physical layer. Okay, so I can store this. And would it matter if it doesn't have a primary key or not? It depends. I can define a table without it having a primary key, a view. But it might make it hard for me to do any sort of querying on it later. So it is something that whoever is designing that table would need to consider. But sometimes maybe I'm just looking for to analyze some information. I don't really care about any specific person. And as you can see, this table, the new view, doesn't really allow me to see the student ID of who's actually failed the course. I just want to see how many people are failing and which departments they're coming from. Views can be used to present necessary information or a summary so you can have aggregated values also being returned. And you can also hide some information, right? So here I have the course table. I have course number, title, and department. And here I also have the student ID of the person who is taking that course. In my course with fails, I only know the department, I know the course number, and I know the mark. So I would know how many people failed 304 and what their marks were, but I wouldn't know who that person is. Okay, and maybe this is some information that I want to Dean to have, but I don't want to give Dean access to our specific students in the CS department. Or maybe the CS department is interested to know how they're doing compared to the stats department for their first year courses. How many people are they failing and how many are we failing? So this allows us to share some information and still keep the privacy of our students. Any questions? Updating views can get complicated. First of all, does it make sense for you to update a view? And the answer is sort of. Let's say if UBC has given the CS department a view for CS students, then the CS department needs to update some information about those students. But would it make sense to always allow people to update values on a view? Doesn't really make sense. And it will be ambiguous and difficult to do so. Let's go back for example here, and let's say now the dean would like to actually play around with this table and would like to add some new information into this table. Quickly discuss it with your neighbors to see would that make sense? And if you want to do this, what are the sort of challenges that you would have if you want to update this table, this view, rather than table? Right? So quickly please, and then we can talk about it together.
to the table. And so the
Right, does anyone have an answer? Would it make sense to add values into that view? And if not, what would be the problem? Yeah.
You can't add anything with values to the view, but it won't affect physically, right?
So the answer here is that, well, you can add values to this view, but it cannot be stored in the physical layer.
Yes. So if you want your database to be updated, like you're saying in the university asking the computer science department to update a student and they have only view, so they update the view, but the actual stored data will be untouched, right?
Then how would you see that person later? So let's say you added a new person into your database and you can't add it to your physical layer.
That's a problem, I think. Because, yeah, you can manipulate with this view, but it has no effect on the real data.
Well, the thing to remember is that I only have two tables, right? I have the course table and I have the enroll table. I don't actually have a course with fails table to temporarily store what you're talking about. If I can't add it to these two tables, then I can't store it at all. If I can't store it at all, then that means next time I query this, I won't see what I just added, because it wasn't added anyway. But why wouldn't it make sense for me to add a value into my view and for that to be transferred into the two different tables that I have? Why would that be a problem?
because the view, it's supposed to be more secure. It's supposed to be a way to just see stuff and not be able to secure. So if you can add stuff, then people who weren't supposed to have access could start adding.
So security could be one problem, right? So the security could be, well, my view is read-only and I don't want to give you access to do anything with it. And I can do that to some people, and I can allow others to insert. So security is one of the reasons, but not the main one. Because I can still stop them from adding if I want to give them just read-only access.
Is it because we don't have SID in the course that fails?
Thank you. So if I want to add this, I need to translate the query that I have here, which has course number, sorry, it has department, course number, and mark. Okay, so these are the three values that I have. And now I want to translate that over into these two tables. If this is my enroll table, what's my primary key here? I need course number and I need SID, student ID. If I don't have a student ID, can I add anything here? No. Then when would it make sense for me to be able to update this? If I have enough information here, maybe including the student ID as well, then it might have made sense for me to allow a person to update the view as they feel like they're doing, and I could translate that over to my multiple tables, so next time when they do the view, they can see what they just added as part of my views. In reality, what is usually common is that if you have one table, and let's say that this table is all students, and if I have a view which is just on this one table and not a combination of tables, with the restriction that I'm only seeing CS students, then this view that is only showing me CS students is updatable with the restriction that the major of the person that I'm updating needs to be CS. So it says, well, you can insert here, and I'll translate that over to our student table as long as you're just adding a new student in the CS department. Any questions? Now sometimes, we're not actually going to cover this in this course, is that sometimes you have materialized views. So there are views that they are so important, or you need to have some kind of access to them, that you actually materialize them and you keep them on the physical layer. We're not going to discuss those much in this course though. How do you drop a view? Dropping a view is pretty simple. You just say drop view name, and you'll drop it. And dropping a view does not really affect any tuples in the underlying relation. If I drop this view, am I really losing any information? No. This was just a definition, and I'm dropping that definition. Another question is, well, let's say I have this view here, which is defined on both enrollment and course. I can drop this, and that's okay. What if I drop my courses table? Would it make sense for me to drop my courses table and still have this view in place? No, because that view is on top of my course table. If I don't have this information, then I can't really build that view. So what you can do is, you can only allow a table to be deleted with different restrictions. So if you say drop table student restrict, then that means that if that table has any views defined on it, don't allow them to delete it. Wait.
What is it? Default restricted casting?
I believe it might be depending on the DBMS, I'm not quite sure.
Oh, okay.
And you can also say cascade, which would mean that if you want to delete this table, then also delete any view that is also built on top of this table. Any questions? Okay, now let's revisit the problem that we had before, and let's see how we can write this. We're thinking about those majors for which their average age is the minimum over all majors. So I can create a view as temp where I have major and average. So this is what the schema of my view is going to look like. And this is the SQL that's going to build my view. Select s.major, and I want average age, and I'm going to keep that as average. From students, and I'm grouping by major. Okay? So this gives me, so let's actually run this. So we'll see what happens. So if I want to do this, it says temp already exists. So it's already there, I can't add it again. So I'm going to say drop view temp. Okay, so now that's dropped. Let's add it. Okay, so now I have created a view temp. I can say select star from temp. Okay, and now I have a view which gives me for each major the average. So now that I have such a view, I can run the query that I had. On top of temp. So as you can see, I'm just dealing with temp as if it was just a normal table. actually not sure what the error is. I think it might be a typo somewhere in it. But you can run that, and as you can see, I'm just using from temp as if it's a table. And really, if you're not familiar with the schema of your database, you can be using views all the time, and you wouldn't even know it's view. Because from this SQL query, if you're just doing select from a table, that could be a table as far as you're concerned. And if you try to insert into that, you might get an error saying, well, you can't insert into that table, and that's happening because either you don't have, you're not granted the privilege to write in that table, or it might be a view that you're not able to write to. If you don't want to use views, then this is the hideously ugly SQL query that you need to write instead. And as you can see, in the from part of this clause, in the from clause, I'm writing a nested query to define the actual view that I'm doing on the top. Right? So if you don't want to use a view, you can say from, and that's a nested query, which is defining the view that I had before. It's just now it's not keeping it as a view, and then I'm doing the rest of it similar to what I'm doing at the top. Any questions? All right, now let's do a clicker question on view. Put it on your own, please. Well, it says select
Oh, okay. That makes sense.
Alright, let's finish the first round off in 5, 4, 3, 2, 1. Alright, discuss it with your neighbors.
Smart. I knew it would be all along. I feel there just wasn't enough time
Yes.
out of the table he is equal to 2. The sum construct, like, I had to do actually the thing
where
to
is
come up with the answer.
Where is it equal to? Only the first one. Yeah, some of these things is great. Correct. But it says count as great.
Kind of like, I tend to, I don't know, I tend to use
Not equal to. No, C is and it's about. That's Yahoo. Yeah, so it doesn't count. It says having. The last one is 5. Can you get it?
Do you have like, do you also have like the expansion?
Sum of 3 to get 12.
Yeah, that's not me. Yeah,
It's the only one to be second.
Is anyone need for 10? Alright, now let's finish this off in 5. Or, I don't know why it already stopped.
Whoa.
This class is
Alright, so let's see. So you're creating a view, and if you're finding this hard, what you can do is you can actually create that view first, so it would make it easier for you to see what's happening. The view says you'll take the values from A and B, you add them up, and then you'll put C next to it. So first row will be 1 plus 1, which is 2, and 3. Next one will say 1 plus 2, which is 3, and 3. Right? So this is how the view is going to be. And somewhere down there you have 2, 3 gives you 5. So you have 2 and 3, which gives you 5. So you have 5 and 5. And also you have 3 and 2, which gives you 5 and 4. So you have these 2 rows as well. Now the question is asking a select clause of another SQL query coming from V. Okay? And now we're asking what's going to be inside here. Is 2, 3 going to be there? 2, 3 is actually part of the view, but not on the query that we're talking about. If you run that query, these are the values that you're going to get. And 5 and 9 is there because it's going to group by these 2 rows where you have value 5, and the sum of 4 and 5 is going to give you 9. And that's the row. As you can see, the first answer, 2 and 3, is part of the view and not the query that we're asking. Anything else? Any questions? Alright, now let's talk about null values. When you're keeping information, there might be some information that you don't know. And you can use a null value in order to contain information that you don't have any information on. If you're doing a var clause, you can use isNull to see whether a value is null for a specific attribute. For example, you can say, select only those people where you don't know their age, where age is null. If you want to do any arithmetics on top of null, the answer is always null. So what is 5 plus an unknown value? It's an unknown value. You can also run binary values with null. If you have something which is unknown or true, then the value is true. If you have something which is true and unknown, the answer is unknown. Because if this is true, this will be true. If this is false, this will be false. And if you want to negate unknown, then it's still unknown. If you do select count from class, then that is going to consider any null values that you have as well. So whenever you're doing count star, it's going to consider rows even if there are some nulls in there. If you select FID, it is not going to consider that null. Let's run these two queries. So if I say select count star from class, I get 23. And if I do select star here, you can see that I have a null here. But if I do select FID, I'll get 22 because now it's not counting that as a distinct value. Any questions? Nope. Now let's look at this. Right, a few more seconds. Five, 4, 3, 2, 1. Okay, so when you look at that, it's going to select where team is carp, so these two tuples will be taken. Runs as null in both of these, so nothing will be returned. But if you're doing count star, it's going to count both of these rows. What?
Why not 2 and null?
Because it's counting. So how many is returned? That's 0. I see what you mean by null because it's unknown, so like it would be unknown. But when it's running that, similar to the previous one that we did here, right? When you're counting FID, just ignore that one and just counted it as 22. No. Any questions? How different DBMSs deal with null is a little different depending on the DBMS. As an example, if you group by in MySQL using, if you group by, it would also have a group of nulls. Right, so you'll get a group for everybody that they don't know something about. Not sure if that's the case for all the possible DBMSs out there. Any questions about null? Right, now let's see what happens when you do select star from students, enroll, and when you're joining these two together. Now what's going to happen is, any student that has not taken any courses, is not enrolled in any courses, will not show up in that table. Right? So if I have a person that's not enrolled in any courses, I will not have that person as part of that table. But what if I want that person to show up there, but just without any courses? So I want to make sure that I have information about all my students when I look at that table. Now what you can do is we could have several special kinds of joins that allow you to have this. Inner join is what we've seen so far, which is going to only give you students that have taken courses. And also, if you have a course that nobody is enrolled in, that course will be lost in this join as well. If you want all of your students to show up, then you're going to use the left outer join. If you want all your courses to show up, then you're going to do the right outer join. And if you want all your students and all your courses to show, then you're going to use the full outer join. So let's do this one. So this is returning 21 rows. Right? And you can see that all my students are registered or enrolled in some course. If I do this one, I'm not going to run this because it's going to, let's try it. No, I know, but there's a bug and it's probably going to freeze. Sometimes it freezes when you try to take out that value. So now it's giving me 34 rows, and what you can see is I have students, Charles, showing up with null, which means that there's no courses that they've taken. And I also have Maria with null, which means that they didn't take any courses neither. However, this means that I get all my students showing up, even if they haven't taken a course. So, as an example, if I have R and S with these two relations, if I do the natural inner join, and natural is similar to what we've seen before. If using natural, attributes that have same name, only one of them will appear in your final results. If I do inner join, then it's going to look at, it's only going to return 1, 2, and 4, because 2 and 2 will join, and then since we have nothing for 3 or nothing for 4, then they're just going to disappear. If you do the left outer join, then that means everything from your R relation need to show up here. So you're going to get 1, 2, and 4. Since 3, 3 is not showing up, you're going to get 3, 3, and that's going to be paired with null. If you do right outer join, Then the second tuple 4, 6 is not joined with anything on the OR relationship, so it's going to be paired with null. And if you do the full join, the outer join, that means you get everything from the left-hand side showing up, that means 3, 3 and null, and you also get everything from the right-hand side, which means null 4 and 6. Any questions? Now let's do a quick question. Now discuss this one with your neighbor. Whenever you're unsure, start by building that relation so you know what's inside it. Does anyone need any more time? Right, then let's finish this off in 5, 4, 3, 2, 1. Some people decided to keep their answers, even though they were outnumbered. Okay, so if you run that query,
Is that the right query there? Okay, I'll check.
this is what you get. Okay, so if you want to answer that question, what you need to do is build that, look at the two tables, and based on the conditions, you need to build that. Then what you need to do is you need to see what is not showing up in either side of that, and you need to add those as well with no. And as you can see,
That's why A.
1, 2 shows up with null on the other side. So since there's nothing that's going to be paired with 1, 2, then you have to add it with nulls on that side. Yeah.
So wondering why is 1 and 2 still there? Because RA, so 1 is less than SB2,
So these two lines are the only ones that you're going to get if you're doing the join of the two.
Okay.
Right? But this is an outer join. And what we mean by the outer join is that everything from the left-hand side must also show there. And everything from the right-hand side must show. Similar to when we were doing the previous example. Here when we did the outer join of these two, this row really is the only one that needs to show if you're doing just the join. These two rows are showing up to make sure that everything from R and everything from S was also showing up in that relation.
Okay. So what does the on mean then?
So the on is the condition that you're joining on instead of the natural join. So you're joining on R.A being bigger than S.B and R.B being equal to S. So that's just your, that's the joining criteria.